Hi everyone. In this session we have to discuss about problems on operational amplifier and oscillator. First we have to read the question, then we will solve the problem. Okay. First one is an integrated circuit that produces an open loop gain of 100. 100 open loop gain means AV equals to 100 and is to be used as the basis of an amplifier stage having a precise voltage gain of 20. Determine the amount of feedback required. What we have to determine? Beta, that is feedback factor. And what they again give? Precise voltage gain means it is G. G equals to what? Overall gain equals to 20. What we have to find now? Beta, feedback factor. First of all, we have to find which feedback it is. It is negative feedback. How means? Compare AV and G. Which is greater? AV is greater. Therefore it is negative feedback. You have to write the equation of overall gain for the negative feedback. G equals to AV divided by 1 plus beta into AV. Now from this equation, simplify the equation and find the beta value. That is G plus G into beta into AV equals to AV. Now G beta AV equals to AV minus G. Then beta equation is beta equals to AV minus G divided by G into AV. Now substitute the value of AV get cancelled. What we will get at last? 1 by G minus 1 by AV. Now you have to substitute the value of G and AV. It is G equals to 20 and AV equals to 100. After simplifying that, what we will get? Beta equals to 0.04. It is the feedback factor value. Beta equals to 0.04. Then go for the next question. An operational amplifier operating with negative feedback produces an output voltage of 2 volt. Output voltage means Vout equals to what? 2 volt. When supplied with an input of 400 microvolt. Input means Vin equals to 400 microvolt. Determine the value of closed loop voltage gain. Closed loop voltage gain means AV means AV in bracket we have to write closed loop CL you have to write. Then AV equals to with closed loop equals to V out by V in. What is V out value? 2 volt divided by V in value is 400 into micro means 10 power minus 6. After simplifying this we will get 5000. It is 5000 gain AV equals to 5000. AV that is gain always in dB. Therefore AV in dB is equals to 20 log of 5000. You have to find this in your calculator, then you will get the 74 dB. Okay. This is what the gain of the closed loop. Next, go for the next question. An operational amplifier has an input resistance of 2 mega ohm. Input resistance means Rin equals to mega value is into 10 power 6. 10 power 6 means mega. Determine the input current when an input voltage of 5 millivolt is present. Input voltage is given, input resistance is given. We have to find the current, input current, that is I equals to what? V by R. Therefore I in equals to V in by R in. Then substitute the value of V in and R in. You will get the answer as a 2.5 into 10 power 9. 10 power 9 means nano ampere. Current is in ampere. Therefore it is 2.5 10 power minus 9 ampere. Next, go for the next question. A perfect rectangular pulse is applied to the input of an operational amplifier if it takes a 4 microsecond for the output voltage to change from minus 5 volt to plus 5 volt. Determine the slew rate of the device. What are all the quantities they given? Voltage is -5 to +5 volt. Input voltage as a -5 to output voltage as -5 to +5 volt, and it takes the time period as 4 microsecond. Then we have to find the slew rate. What is the formula for the slew rate? Slew rate is equals to delta V out by delta T. That is, there is a change in the voltage with respect to the time. This is called slew rate. Then you have to substitute the values. Change in voltage means -5 to +5 means it is 10 volt. Minus of -5, minus of minus is plus. You have to add those voltages, then you will get the 10 volt. Divided by change in time means what they given? 4 microsecond. 4 into 10 micro means 10 power -6. After simplifying this, you will get the 2.5 volt per microsecond. This is what the slew rate of the amplifier. Now go for the next question. Wideband operational amplifier has a slew rate of 15 volt per microsecond. If the amplifier is used in a circuit with a voltage gain of 20 and a perfect step input of 100 millivolt is applied to its input, determine the time taken for the output to change level. What are all the quantities they given? Slew rate equals to what? 15 volt per microsecond, and the gain is AV equals to 20 and Vin is 100 millivolt. First we have to find the slew rate. From the slew rate equation, from the gain equation, we have to find the Vout value. Vin is given. First we have to find the Vout, because in the slew rate formula, observe that Vout by delta T. Therefore we want Vout. Therefore we have to find from the gain equation AV equals to Vout by Vin. From this you have to find the Vout value. Substitute the AV and Vin value. From that we will get Vout value as a 2 volt. Okay. Next, from this slew rate is given and Vout is there. We have to find the what they given in the question. We have to find the time taken for that output to change the level. Change in the time, that is delta T. Delta T equals to Vout by slew rate. Substitute the value of Vout and the slew rate. At last you will get delta T as the 0.133 microsecond. Okay, delta T is the change in the time. Next question is, an inverting operational amplifier is to be operated according to the following specification. They are given the specification of the operation amplifier. From that you have to find the frequencies and capacitor values. First, what are all they given? AV equals to -100. -100, because -100 it is inverting amplifier. From this you have to find the RF value. RF equals to AV into R1. It is AV value you have to substitute and the Rin value. From that minus get cancelled. Then you will get the RF value as the 1000 kilo ohm. Okay, you will get the RF as the 1000 kilo ohm. First you have to find the Cin from the equation F1. F1 equals to 0.151 divided by Cin into Rin. From this equation you have to find the Cin value, because frequency is given. Therefore you have to find the Cin value. Substitute the value of F and Rin. You will get the Cin as the 63 nanofarad. Okay, from the F2 you will find the CF value. Okay, lower cutoff frequency and higher cutoff frequencies are given. You have to find the C in capacitance at input side and the capacitance at the output side. Okay, CF. After you have to substitute the value of F2 and RF, you will get the CF value as the 10.6 picofarad. Okay, next go for the next question. Determine the frequency of oscillation of a three-stage ladder network oscillator in which C equals to 10 nanofarad and R equals to 10 kilo ohm. In the three-phase RC phase shift oscillator, what are all they given? C equals to 10 nanofarad and R equals to 10 kilo ohm. R means these are feedback circuit. R and C are connected each other. Therefore, R equals to R1 plus R2 plus R3 and C equals to C1 plus C2 plus C3. From this, overall they given capacitor and resistor. You have to substitute that in the equation F equals to 1 by 2 pi root 6 into RC. You have to substitute the R and C value. You will get the frequency of oscillation of RC phase shift oscillator. Okay. This root 6 is come from root of 2n. N value is 3 because 3 feedback circuits are coupled. Therefore, 2 into 3 means root 6. Okay. You will get the frequency of oscillation is 647 Hz. Last question is, it is based on the Wien bridge circuit. Figure shows the circuit of a Wien bridge oscillator based on an operational amplifier. If C1 equals to C2 equals to 100 nanofarad, determine the output frequencies produced by this arrangement when when R1 equals to R2 equals to 1 kilo ohm and B when R1 equals to R2 equals to 6 kilo ohm. They have given a 2 resistance value. You have to find the frequencies for A and frequency for B and C value is given as a 100 nanofarad. The frequency of oscillation for the Wien bridge is F equals to 1 by 2 pi CR. Then substitute the C value and R value. For A, R value is 1 kilo ohm. Then C value is 100 nanofarad. Substitute the C and R in the equation. Then you will get F as a 1.59 kilohertz. Then for B, R1 equals to R2 equals to 6 kilo ohm. You have to substitute the R and C value. C value is same for both these frequencies. Okay, you have to substitute the R value as a 6 kilo ohm and the C value as the 100 nanofarad. Simplifying the equation, you will get the 265 Hz as the frequency of oscillation for the Wien bridge. These are all the problems on operational amplifier and oscillators. Okay, thank you.